It's on the way towards, like, if you're walking. Yeah.
All right. How are we doing?
I get to record this session, Nick?
I am.
Great. What are we doing today?
What is it?
Are we going over the file?
We are continuing our review.
Nice. Which happened yesterday?
Which we did.
Are we allowed to have?
I was here yesterday.
No, we're gonna split them.
Yeah, so 8 pages single-sided or 4 pages double-sided.
Like the midterm when we were allowed notes.
Yeah.
Being allowed notes.
Yep, same thing.
I thought you were going to say 8 pages double-sided.
What day is it on?
Yeah, there'll be a lot of notes.
Yeah.
So, but yeah, 4 pages double-sided. You can write tiny. You can computer print. It's totally your choice.
Monday or Wednesday.
Whatever works.
How's our?
So final exam, section A, Monday at 10 o'clock. Section B, Wednesday at 11 o'clock. And if you're in CSE 215, it's Monday at 12. Yeah. Don't sweat regular expressions. I mean, the totality of regular expressions that we discussed was really, there's a half-page cheat sheet. I'm not going to throw a lot of them on the exam, but they're good to know anyway. But yeah, for the exam, not too much. If you're taking 215 in winter and have not signed up, please, please, please sign up. I think only about half the people who need to take it have signed up, and we can't open a new section if we don't get people signing up for it. And if we don't open a new section in time, then there won't be a new section, and that would be a big problem. So if you need to take it, make sure you sign up for it. If you can't, come and talk to me. All right, we had talked about permissions and change mode yesterday, and we very quickly talked about setting variable values because I said we'd already talked about that. So and the one thing that maybe we didn't talk about enough, just make sure if you want to do an expression, right, if you want to evaluate arithmetic, put it inside $, paren. So, all right, x equals 2 plus 3. If I look at the value of x, it's just 2 plus 3. And if I say x equals $paren 2 plus 3, and I look at x, now it's equal to 5. All right, so if you want to treat x as an integer and add 1 to it, don't do this, because now x is equal to 5 plus 1. Right. If I do x equals $paren x plus 1, now x is equal to 6. So it's just something in bash. You've got to do it that way. Otherwise, you're just doing literal string expressions. I don't know what happens when that counts down to 0, but we're still here, so it's okay. All right, built-in variables. When you have a script in particular, we can use $1, $2, $3 to get to the arguments on that script. So, so there's all these different variables that we can get to. All right, so let's just run some jump code here. So go, this is a test. All right, so $1 is this, $2 is, $3 is $4 would be test if I had printed $4. So this $sign followed by a particular integer just gives you that argument from your command line. $number sign tells you how many things are on the command line. This is a test for arguments. That's what $number is. $* gives you all of those arguments side by side as a single variable. $sign is your process ID. Nothing to do with command line arguments. It's the ID of your current process, which is 25710. That's the process ID of bash. When I ran the script, it told me that my process was 25744. That was the process ID of this go command that was running. Okay, and $? shows you the return value from the previous instruction. So if I echo $? it's normally a 0. If I have an error, $? is non-zero. If I look again, it's a 0 because the echo command returned with an exit status of 0. All right, Zenity, just know the basic dialogues, calendar, entry box, that kind of thing. I'm not going to ask you a bunch of Zenity questions, but it's basically a bash command that we can run to display GUIs. You put switches on it to say what kind of dialogue you want, to tailor it to say what the title should be or a timeout or things like that. And when Zenity exits, it's printed out some piece of information usually that you can capture by throwing the command in back quotes. We already talked about back quotes. GCC, right, that's our compiler. We know this already. Main things to know for GCC, -o output file and source1.c, source2.c, main.c, whatever, right? And this -o output file can be in the very beginning, it could be at the very end, it could be in the middle. Okay, the important thing is -o has to be followed by the name of the output file. Okay, if I do this, gcc -o source1.c and so on, I've said when you're done compiling, take that program you built and name it source1.c. I've just destroyed my source1.c file. Okay, people aren't doing this quarter, which is really cool. So don't do that. Do that.
Can you go back after it's compiled?
It's gone. Right.
You could copy it, make a copy of it.
You can pull it from Git if you're pushing over to Git, or you can make a copy of it before you do anything, or make copies periodically, which you really want to do because this is really easy to do. Right? I mean, I do this. I've been programming for 30, 40 years. I still do this sometimes. It happens, you know, it's like locking your keys in your car. It's going to happen sometimes. So
Don't tell me that. That sounds horrifying.
you've never locked your keys in your car?
I mean, I have. It was nice,
Okay.
actually.
Was the car running?
No.
That's when it's really bad.
Oh, God. I have a button start, so that never happens.
Okay,
We were
cool.
in the gorge, and it was like,
Oh, yeah.
we weren't going to get home. It was
Yeah. And then you start thinking about clever ways to break in.
Yeah, it was in
and-
the trunk.
Yeah.
It was not really.
Trunk would be worse,
It was
actually.
scary, dude.
Yeah. So yeah, make backups of your files and your keys, and this won't happen to you. All right, and -g we have to put in there somewhere if we want to compile with GDB support. So I could put a -g over here, I could put it here, I could put it here, or here, or here, but you can't put it in the middle of the -o output file, right?
What is the
This?
Yeah.
Instead of making your executable a.out, it calls it whatever your name is here. Because if I just say gcc, bunch of C files, the executable is called a.out. And then all your programs have the same name, a.out, which is kind of goofy. So this lets me say, call the output file PA4, or index, or super duper product or something.
What does dash C do? Totally missed the whole
So dash C, dash C says I don't want to build an executable file yet. I just want to do the compile part of this and create a .o file, which we call an object module. And this gets into more with makefiles. Right, makefiles, we typically, if we have a lot of files in our project, typically we compile them from .c to .os, and then we compile all those .os together into an executable. And then if we change one C program, we just recompile that one C program to a new .o, and then we link those .os together into the executable. Because combining .o files is fast, compiling .c files is slow.
We only have to compile it once, right?
If you don't change it, you can just use that .o forever.
So what's the point of this? Like, you've only executed once since you get the executable, right? So why does it matter if you do it fast?
So what about when you make a change?
Just recompile?
What about when you decide just recompile what? So if your program consists of 50,000 C files, and you change one of them because you forgot to print your name in the beginning of it, right? Do you want to recompile 50,000 C files because you changed one line in one file called intro.c, right? And it might take 8 hours to do all that recompilation. So if you compile all of your .c files to .os, you have 50,000 .o files. Okay, you make a change to one file, intro.c, compile that to intro.o. It's a 10-line program. That's easy to compile. Now you have 50,000 .o files that are all up to date. You just link those together, and that's a really fast operation.
Oh, and how do you compile the .o files?
We can actually just say gcc-o main file 1.o, file 2.o, right? File.o, whatever the .os are. And GCC will notice that, you know, these are .os, and it'll treat it as a compiled C file and just link it. And so when you look at make files, this is typically the kind of thing that you see.
What's a make file?
This is a make file.
Oh, yeah, right.
So yeah, we can talk about make files next. So make files are a way to basically capture this more carefully controlled compilation process. So I have a main program, and it consists of 3 C files: main.c, sub1.c, and func.c. And you know, in 122 we just say gcc star.c, and everything gets compiled, and we get an a dot out at the end, right? So the problem is, you know, if I change func.c, I'd rather not recompile main.c and sub1.c. So, because it takes too long. So this is a recipe basically for how to build our output program, which I'm calling main in this case. And it's saying to build this program called main, I need to have these 3 pieces. Main.o, sub1.o, func.o. These 3 objects have to exist, and they have to be up to date. And if they are, I can compile them together to make my output object main, and I need to put in the -lm switch because I'm using a square root inside one of them or something. So this is the procedure for making main, assuming that I have all of these pieces. Well, if I don't have a func.o, it will look for a recipe for func.o. It'll find it right here and say, well, I need to have func.c. If I don't have a func.c, it'll say I can't make this. But assuming I have a func.c, it will go ahead and it will compile it with the C switch, and this will make a func.o. And it'll come back up here and say, okay, func.o is up to date, that's up to date, that's up to date, I'm good to go, and it'll go ahead and do this. And this is, you know, a command that should be executed to build your target. So it's a GCC command. And when we say GCC, we don't include the .h files in here. We don't say GCC main.c stdio.h, right? Even though we're including that, we just list the C files that we want to compile. But this line up here lists the things on which this is dependent. So if sub1.c includes a file called all.h, we have to list all.h up here on the dependencies. The reason being, if all.h changes, the make utility needs to know, hey, all.h changed and sub1.o depends on all.h, I better re-execute this command. Okay, so this first line is the dependencies. The second line is what you do if those dependencies are satisfied to build whatever that target is. Yeah?
All.h is what is all.h?
It's a hypothetical include file.
So one that you make?
So one that I would make that might have like function prototypes and define statements and things like that.
And to use make files, can you do make func.o?
Yeah, I could say make func.o and it would just try to make func.o. If I just say make, it'll look at the first target and it'll act as if I said make main. And then I did something here where maybe the way that I write code, I wrote 3 include files, one with function prototypes, one with define statements, and one with something else, comments or something, I don't know. And I should include all 3 of those in my sub1.c, but I don't want to say number sign include, number sign include, number sign include. So I have a target for making all.h, right? All.h says, well, it depends on these 3 files, and if all 3 of those exist, here's the command I execute to make all.h. And it just says, type the output of those 3 files and collect it together into all.h. And now if I want to change a prototype, I can just go into my prototypes.h, edit that, and when I say make, it'll say, oh, prototypes.h changed, so let's remake all.h, and then it'll go through and it'll say sub1.o depends on all.h, so it'll recompile sub1.c, and then it'll say, oh, main depends on sub1.o, so it'll recompile those .o's and make a new main. So it's managing all this for you as long as you create this sort of blueprint for how main comes into existence. And then there's these bogus targets, like if I say make clean, it just says let's remove all of these things. And it's not actually making anything at all. It's a convention that if you say make clean, it should get rid of all the compilation results that have potentially happened. And if I say make install, it'll check to see if main is up to date, and if it is, it'll copy it into my bin area. And so typically a make file, you say make and then make install, and it pushes the file into an executable area, and it pushes the manual pages into the right place, and moves libraries and all sorts of things like that.
Crazy.
Pretty crazy. And you know, if someone comes at you in the street and says, you know, give me a make file or I'm going to get really angry at you. Right, that's a perfectly valid make file. Right, it really just says to make main, I need main.c, and then here's the way that I compile main.c.
Happens to me all the time.
And
Yeah.
And then you just click make file.
Then you just say make, and it'll look for something called make file.
I see.
And it'll act accordingly. Right. But the spirit of a make file is to be able to do more complex, you know, management of how things get compiled and linked, and so they usually look more like this. And make files that you'll download for projects from the web are, you know, thousands of lines long and get really complex quickly.
Keep missing this, but what's the point of having multiple of the headers by
Like main and main.o and sub1.o.
like main.o and sub1.o?
So if I say make, it'll try to make main,
Yeah.
and to do that it needs to have these .o files. What if it doesn't have those? What if all I have in my directory is my make file and my .c files and my .h files? Right? It's got to know, well, where does main.o come from? Well, I'm telling it. To make main.o, you need to have main.c, and then here's the command that you execute.
Why don't you just throw all the .o's in a single line
Um,
so that we compile everything
because that would recompile everything.
So in order to separate them, when it's necessary, you put them on different lines.
Mm-hmm. Yeah.
And the left side of the column is just to reference
The
name for them to like edit.
yeah. So this is the thing that we want to build,
Okay.
followed by a colon and the list of things that it depends on. And then the recipe, this always starts with a tab. And it's got to be a tab, not spaces.
Okay.
Right, so those are control I's, which are tabs. If you put in spaces, it will complain.
Can we see you do it? Can we see you use one of these?
Yeah, except they don't have those files in here.
Stop.
Yeah. Let's just get rid of the all.h dependence. Alright, so it's trying to do these compilations. So it compiled sub1.c and func.c. It had already compiled main.c up here. Right, so it didn't have to recompile that. So it did the 3 compilations, but now it's trying to link them together, and it's saying, hey, there's no main program because my main.c is empty. And if I try to say make again, it doesn't recompile anything, but it still tries to link these together.
So main is required.
So you need a main program if you're going to actually make an output executable. So if I get rid of my func.o and I say make, it'll recompile func.o from func.c, and then it'll try to link. All right, GDB, no basic GDB commands, right? So what are our main ways of interacting with GDB? Compile with a G switch. To run GDB, it's just GDB and your program name. And then you get a prompt, and you can do a number of things. You can say list to look at source code. You can say print and print a variable or an expression or a function call or pretty much anything that you want. You can say break, and you can put in a line number, or you can put in the name of a function. And breakpoints basically say when you're running, if you get to a breakpoint, stop running. Come back to the prompt.
What do you mean by name?
Like a function name.
Function?
Like I say break my function, and it'll stop at the first line of my function. Start is how we start the whole action. Continue is how we tell it to keep running after it's hit a breakpoint. And then we can go line by saying next or step. And next is a step over. So if our current statement is a function call and we say next, it'll come back after that function returns. If we say step and our current line is a function call, it will stop after the first line of that function. So it's a step into versus a step over if you've done 270. I feel like there's one more. Oh yeah, watch. We can say watch and put in the name of a variable, and if that variable changes value, it'll be like hitting a breakpoint. It's called a watch point, and it'll stop executing and come back to the prompt. So we use the debugger to run our code basically in a controlled way, see what it's doing, look at the values of variables, step through certain sections, have it run full speed until it gets to certain spots, and then come back and let us look at the values of variables, step single lines, and so on. There's also X for examining memory, which we'll do a lot of in 222, but not so much here. So basic GDB, more just kind of the spirit of it. So tar, tape archives. All right, so here's a directory. It has a bunch of .c files in it. And let's say I want to save those on a flash drive, or I want to email them to someone or something like that, right? So tar, 3 versions of this that you should know. Tar CVF says create a file, an archive. So tar CVF, archive name, which I'm going to call mycode.tar, and then either a list of the files that you want to put in there, or files separated with spaces, or a wildcard or whatever. And if I just say tar CF, it does it, and I don't get any feedback. So I recommend putting in the V, which means be verbose. So CVF says create an archive, and it shows you a list of all the files that get added to that.
What?
So TVF says give me a table of contents for an archive. So TVF, mycode.tar, and it shows me what's inside my archive.
And it shows you who did it.
And it shows you who owns it, and how big the file is, and when the file was created or updated, and the permission bits on it, and all this other stuff. And all that stuff is saved inside the archive. So now I can move this this stuff into another directory. So here I'm in a totally new subdirectory called sub, and I have a mycode.tar. The last version of this is xvf. It says extract from the archive. So I can extract from mycode.tar, and now all these files are in my current directory. And the same ownership, the same permission bits, the same timestamps, and so on and so forth. Well, if I'm creating these in my directory, they'll have my ownership on them. The same permission bits, timestamp, names.
Why not just use .zip?
You can use zips also,
Okay.
but tars are better in some way. I don't know why. Someone asked that previous section, so we actually played around with zip, and zip seems to work as well, but I suspect if you put this on a Windows system and you try to unzip, you lose some of the information, and it doesn't play as well with quirky file names.
That makes sense.
And so on. And this is recursive, right? It'll go down into subdirectories. So if you have a whole directory tree, right, you can archive all of that with a single tar command.
Versus just the files with the zip.
Versus just, well, zip will also go down to subdirectories, I think. I think there's a way to specify it. So at the end of spring quarter, usually the August after the quarter has ended and everybody's graduated and moved on, and I get the system ready for next year, I go into the top level directory /home, and I just do a big tar command. I just say tar cvf 2018-19 star, and it takes every file that every person on the system has under the home area, and it throws it into a big archive, and I push that over to GitLab, and then I clear everything out and get the system ready for the next year.
You steal our work.
Yeah.
Wow, thanks, Nick.
In case someone becomes rich and famous, or when someone becomes rich and famous, I can sell the code for this was their first C program. Put it on eBay.
You can expose them with that cheat folder you have.
Yeah.
So I think I asked on the Discord, but are we gonna be able to access the server between quarters?
Yes. So the server will continue to be up, and actually after spring quarter ends, it's usually available through August, and then right before the next year starts, I'll clear it out. And I tell people that their stuff is gone, but I actually do back it up and let them know if they really need it, I can get it for them. And that's happened a few times where someone's someone from 2 years before just pinged me the other day and was like, I need to do such and such, and I know I did this in the class, but I can't find my code, and is there any possibility you still got it? And it's yeah, I'm good.
Nice.
So, but it's all locked down, so it's protected. All right, so tar, CVF, XVF, TVF, right? Those are the only ones to worry about. Regular expressions, don't go too worried about it. There's a half-page cheat sheet on Canvas, but I'm not going to ask you to do a bunch of regular expressions. Sed, so let me write down tar, CVF, TVF, XVF. So this is create, this is list, and this is extract. And there's no dash in the front of these. It's one of the few Unix commands that doesn't have a dash in front of the arguments.
Would you say that tar is more affordable cost system?
Tar is totally standard for Unix.
Unix.
It's been around forever. Every Unix system understands it. Zip is a little bit of a moving target, and some people do zip 7, and some people do bzip and gzip and all of these things. And for Unix, it's almost always tar.
Does Windows use tar at all?
I don't think so.
Where
It
else?
may, if you hit a tar file, if you right click it and say extract, it may actually know how to do that now.
It didn't work.
I think he used
Didn't work.
7-zip to extract tar.
Yeah,
Yeah.
7-zip works well.
Yeah, so
Okay.
you have to get like a third-party program.
Yeah.
Yeah. Interesting.
I mean, you should probably have one anyway.
Yeah. All right, so tar, okay, so sed is the whole thing, but if you know this much about sed, you're in pretty good shape. Sed, and then inside single quotes, you can do one of these substitution commands like we do in VI when we say colon. And it'll look for occurrences of this old pattern and replace it with a new pattern. And these can be regular expressions, and these can have register replacements and things like that. And this happens once per line. If you put a G at the end, it happens everywhere on the line that it can possibly happen. And most of my life, I've lived knowing nothing more about sed other than this. And my life has been pretty good so far. So if that's any indication, you know.
So do I have to use the S? Like the
So the S means substitute, yeah. Because you can do all kinds of other things in here. It's a whole programming environment. And similarly, awk. There's a lot to awk, but this is one of the more useful things we can do with awk. Basically print out fields from output. So the print $4 means print out the fourth field of the output. So if I do an ls-l, I get all of this information. Maybe I want to know what my biggest file is in here. Well, if I count, this is column 1, 2, 3, 4. It looks like column 5 is my file size. So I could say awk print, or I could say ls-l, and I could pipe that into awk print field 5. And then 6, 7, 8, and then let's print the name, field 9. And there's a list of my files with the file size next to each of them. And I could pipe that into sort, and there's a sorted list of files by file size, except I didn't sort numerically. Alright, so there's a list of my files in increasing file size. Now there's switches you can put in ls to do that also, but it's sometimes quicker as you just cobble commands together.
What type is the file sizing? Is that bits or
That's bytes.
bytes?
Yeah, so characters basically. And I can put that into head 2 to see like my smallest file. Or just see my biggest one.
So sed is for like replacing things, grep is for kind of searching for stuff, and awk is processing.
Yeah, that's not a far off characterization. Sed is primarily for dealing with things in a line at a time. Take a line, do the substitution to it. Take the next line, do the substitution. Awk is more like on each line we want to do something with the fields inside that line. Right, so it's kind of field oriented, and grep is for searching.
Is grep going to be on the
You should know that grep is used for searching, but
GREP.
grep. So grep, thing that you're searching for, and then a file name just searches for that string in the file name. Yeah, so grep pattern. Grep pattern file. And if you say dash V, that reverses it. It shows you lines that don't contain that pattern. If you say I, it says ignore case. And that's the totality of my grep knowledge. All right, bash programming, start with a shebang. Comments start with a number sign. We talked about these special $sign variables that you can use to get arguments. $sign question mark uses a return value from a previous command, from the most recent previous command, which we can actually use to make scripts that that give us values. Right? At the end of a script, if I exit with a numeric code like 27, for example, and I look at the value of $sign question mark, it'll be that value that I passed to exit. So you can make a script, you can run it from a bash script by just using its name, but you can also grab a return value, a small integer, by looking at $sign question mark. Or the more typical way, if you run a script and it prints out some value, I can say, you know, x equals back quote, name of the script, and then that variable will have whatever value was printed. So different ways to functionize scripts. Variable assignments we've talked about, ifs, thens, else's, while loops. So make sure that you know about if, while, for in bash. So we never do for loops in this class. I should take it out of here. I've never talked about for loops, okay, and generally I'll say don't use for loops on exam questions. But while loops, right, while, space, bracket, bracket, space, condition, space, bracket, bracket. Really particular syntax. Do, statements you want to do, and then the word done. And condition is usually either comparing strings or comparing numbers. If you want to compare strings, use double equal for equality, exclamation equal for non-equality. If you want to compare numbers, use the dash GT, dash LE, all of these things. Right, so these are good examples of the kinds of things that you would do. If you want the value of a variable, put a $sign in front of it. If you're using strings, you can use $signs to evaluate a variable, but throw everything inside double quotes. Yeah?
Is there a reason you don't like for loops?
Yeah, because the syntax is a little different, and then people start mixing syntaxes together.
That's specifically just a batch.
Yeah, and it's really just for 224, because in my personal life, some of my best friends are for loops, but it just keeps things getting less confused.
Is there any way of actually comparing characters of a string in bash?
What do you mean characters?
Like matching the character in the string,
See if a character is contained in a string? Sure.
Is there an array? Yeah, there is an array.
So we haven't talked about arrays in bash, but there are really powerful array mechanisms. But you could use grep, right? So you could use grep on, you could echo the string, pipe that into grep, and search for your character, and then check $question mark.
You can throw grep into your script, right?
Yeah, absolutely. Yeah. So.
You spelled echo wrong.
I did.
He knows what he's doing.
Sometimes.
Sometimes.
Right, so I echo hello, pipe that into grep L, and let's throw our error messages away. And look at $question mark. Okay, it's a 0. That means there is an L contained in there. And if I search for an X and I look at $question, it's a 1. That means there was no X in there. So that's one way to do it. And again, there's most likely utilities or things you can do in bash that will do that specifically. But if you know a way to do it, you know. All right, so numeric comparisons, you have to use these old school types of equality symbols. If you want to do logical combinations of ands and ors, you can put them outside the double brackets, double ampersand for and, double pipe for or. And I get a lot of people who like apologize for their ampersands on exams, or give me a translation guide for this symbol is an ampersand and stuff. When I was first learning programming, you know, you write a lot of print statements. Well, you could use an ampersand, and the interpreter took that as a shortcut for print. And so for the longest time, ampersand in my mind meant print. And I was always, you know, writing my code on napkins at lunchtime. And I remember spending about an hour practicing ampersands because I had to write them so often, and it was like really weird at first. So I feel your pain.
How does one draw an ampersand? It's like,
I don't know.
if you draw an
I mean, I start down here, and I go like that.
Okay, so you start with the tail?
So I start, I guess if that's the tail, yeah. And it's kind of like an 8, but I cut it short and then I cross over.
Is it okay if we do E line?
Give me a translation guide.
For each,
Yeah, yeah.
E and then the line?
Yeah, that's a standard ampersand.
Okay.
If I think about this too much, I won't be able to draw them anymore. All right, if statements in bash, if condition, then stuff to do, fee. If there's an else, if condition, then stuff to do, else, more stuff, fee. And if your else should be followed by an if, then you use a special if condition, then stuff to do, elif condition, then stuff to do, elif condition, then stuff to do, else, last stuff to do, fee, and so on. We talked about $paren. Don't worry about checking for legal numbers. We've already done that in the midterm.
Is it safe to say that the midterm, it won't be anything like the midterm?
The final will be a lot like the midterm, but things that I specifically asked you to do on the midterm probably won't be on the final.
Okay.
But it'll be very, very similar. So it's 5 programs, 25 short answers.
Oh, shoot.
25 students.
Yeah.
My guy.
Short answers, you know, short.
2
And you did 5 programming questions on the midterm,
Oh.
right? And you got twice as long here. Yeah.
Oh, you gonna? I know this is kind of early, but like, are you gonna go over the algorithms for bash?
So when I put algorithms, I just mean be thinking about algorithms, right? How do you define the set of steps that you need to do some task? So the point there is don't memorize programs that you've written, okay? If you did an ODP where you printed out some word a number of times, right? Memorizing that code doesn't do you any good, right? Refreshing yourself on how you came up with the code, right? That's the more valuable part. So figuring out the steps that you wanted to do. Oh, first I needed to parse this argument and turn it into an integer. And then I needed to make a for loop that counted up that many times, and inside the loop I needed to print this word. That's how I got this thing that prints this first argument a number of times specified by the second one. Right, so in your studying, be thinking about algorithms. How do you come up with the steps to do something?
So do you recommend, so like, there's 5 big coding questions on the exam? Can we just do lead code or like HackerRank?
Do what?
Lead code or HackerRank, please?
What are those?
Like practicing coding
Oh,
challenges?
sure. They're probably more ambitious than most of what I'm going to ask you to do, though. Yeah, I mean, look at the midterm for the kind of sort of level of questions that I'm likely to be asking about.
Can I get one back after this?
Yeah, you can come to my office. Yeah, so I'm not going to ask you to write a phrase indexer on the exam, or a high-low game or things like that. But I might ask you to write something that has the user input a number, and if it's not between 1 and 3, asks them to enter it again and keeps doing that, and then prints out that number times 2 or something, right? That's not a hard or a useful thing to do, but it tests a lot. Not hard compared to, say, writing a whole matchstick picking game. All right, so we talked about variable assignments, $paren, read for input, echo for output. And C programming, there's really nothing to talk about here. I talked about it a little at the end of the previous video. But syntax, arrays, include statements, types of variables, characters, integers mostly. Be comfortable with strings. Okay, string is an array of characters. Arrays do not have a native length. So we either need to specify how long an array is, or we need to do something like, say we're going to put a character 0 at the end of the useful part of this array. So that's what a null terminator is. Know how to do argc, argv, know how to do things like is space, 2 upper, 2 lower, and so on. Yeah?
Anytime we throw in a null terminator before the index is done going to the end, does that chop off the rest of the array?
No, it's just plopping a character in there. But things like string length, string compare, printf are written so that once they find a null terminator, they stop. They say that's the end of the string. But there is no end to a string, right? A string is just a location in memory. It's one location. And we just assume that starting there we find characters. And we just go until we find a 0 and we say, well, that must be the end of the string. Don't worry about fopen, fclose, fflush, fprintf, because we didn't go over those. Know how to do fgets, know how to use getcar, know how to write functions, call functions, pass things to functions, return things from functions, and again, algorithms. Oh yeah, and argc, argv. We didn't get to that, but we talked about it at the end of the previous video. And you've used argc, argv on pretty much all your C programs. So a way to pass arguments in. All right, I will see you probably on Wednesday or Monday if you decide to take the other one, or in 2:15. Have a good weekend. I will see you next time.
Surprising.